Okay, so we looked at a few examples, and I just want to put another one up that is kind of a bit longer, but just bear with me and I'll explain what it does exactly. So what this, a bunch of functions, so we use 4 functions here. So first of all is the function we used before, which is just called print array. What this function does is simply prints out the array. We saw how this works before. Then we have the function which finds the index of a number. So we send the array in and the number we're looking for. So let's just say that we have this array. And let's say that we want to find where our 6 is located. We would use this function to get the index of 2 because that's where our 6 is located. And then we have the swap numbers in the array, and what this does is just it swaps the numbers in an array. So we send the array in, we send the number 6, for example, and the number 12, and what ends up happening is this will end up swapping these 2 for us. And that is maybe a bit abstract because you're not exactly sure what's going on, but just bear with me. So what ends up happening in these 2 functions? So let's just say that we see how the array is. We'll call the swap numbers in array function. We'll send the array in, the 6 and the 12, and then we'll print the array out as when the function is finished. And you can see that it works. It works fine. The 12 and 6 have been swapped, so that's great. So what ends up happening? Well, we send in the array and the numbers. So the first index, we first need to find the first index of the first number, so of the number 1 in our array, and this is exactly what this function does. So we call this function, and we send in this array. So we get the array in this parameter, and then we send it in as an argument, and then it becomes a parameter for this function. And the same goes true for number 1. So in this case, the number is number 6, and the array is just this array. And we are just looking up until to the point where our array of I, so our current array, so our current value that we're looking for in an array, matches the number we are looking for. So when it's 6, we will return the value of E. And I didn't explain this before, but if you just return the value in a for loop, it will actually function as a break as well. So we would return the value of 2 because that's where our 6 is located, and we would save it in index 1, and this for loop will stop executing. So the same thing happens for this function, and we are sending in the array that we are looking the number in, so in this case it's this array, and we are looking for the number 2, which is 12, and we are just looking for the number 12 while looping. So we first check 2, it's not, 6, it's not, 9 is not, but 12 is the number we're looking for, and we just return that, or we return the index of 12, which is 4, and we save it in this one. And then we perform a nifty swap, and this is just something that Lua knows how to do if you write it like this. So array of index 1 is index 2, and array of index 2 is index 1. Beware, if what you did is wrote this out this way, it wouldn't work, because what ends up happening, the index 1 gets overwritten by index 2. So at this point, index 1 has the same number as number 2. So that is not how you actually swap 2 values. What you would have to do is write this out, but it's much more elegant. So we would have to create a new temporary variable, save the first number, then replace the first number with the second number, and then the second number becomes the first number with the temp variable. But you don't have to worry about that too much. What you do have to worry about is just this simple string, and what this ends up doing is swapping them for us in the right manner. So one thing I want to explain here is, you might be wondering, right? Okay, so we send in the array here and things swap around, obviously, but the values don't change. So what would happen if we maybe wanted to do something like this? So let's just say we want to swap numbers, and I actually forget to change the name, but doesn't matter. So okay, so let's just use the function swap numbers and create 2 new variables called a is 3 and b is 5, and we would say, okay, swap numbers a and b, okay, and we would just print out the a and the b. And if you just run this, what would end up happening, you would see that a is still 3 and b is still 5, and that's a bit odd, right? Because we did the same thing we did here, right? We just swapped 2 variables basically. So here we swap the array, and here we swap the a and b. But what ends up actually happening behind the scenes, the variables as numbers get sent in just as values. So what ends up happening here, another a is created that only exists locally, and I'll explain this the next, what is locally but what is not. But what you have to remember that the actual reference to the variable is not sent in this function, only the value. So this function only gets the number 3 and the number 5. So what ends up happening is just the values of 3 and 5 are being swapped, but not the actual variables. But with arrays, when you send them into a function, what ends up happening is you actually do send a reference. So if you do anything in a function to an array, like swap them, add a number, it will also be visible when you return from the function, as opposed to the actual variables, which only have values. The differences that you do in the functions won't be noticeable when you finish with executing the function. So, and the differences will only be visible, of course, if you return a value and then assign it to a variable. But if you just do some operations inside, they're not going to be, unlike I said, arrays which are sent by reference, and if you do any changes inside the functions for the arrays, then those changes are also visible outside of the functions. And that's a bit confusing, but hopefully when I explain locality and globality of variables, it'll make just a bit more sense. Okay, so I mentioned this thing called locality and globality of variables, and I'll try to explain it in my best way possible. So you saw that things acted kind of differently if you sent in an array as a parameter, or if you sent a variable as a parameter that had a certain value. So let me just give you a very simple example called function increment, and what we want this function to do is just create or just increment our value by 1. And if we just set a is 1 and we would call it increment of a, and we would print out the value of a, and we just try doing that, of course that wouldn't work. Even though they have the same name technically, what ends up happening is that a new local variable is created inside of the increment and it gets added 1. But because this a does have a value of 2 at this point, it doesn't mean that the value of our a outside will change. So if we wanted to kind of do that, well, what we would have to do is return the value of a plus 1, and we would save it to our a, and this would work as expected. So this is a bit odd, but you might say, okay, so what's the deal with this local thing that you put in front of variables? Is that really necessary? Well, it depends on some situations, but in functions, generally what ends up happening, the variables are created locally, so you don't have to do that. But sometimes what you want to do, maybe as an example, is you would create a new for loop. Let's just say it goes from 1 to 2, and what it ends up doing is just adding a to itself. And if you just print out this a, what ends up happening, of course, it gets increased to 3, and that's great. But if you just said that this is a local a, what ends up happening is that here a new variable called a, which has the same name as this one, but is not the same variable because this one is local, and this one stops to exist as soon as this for loop ends. So this a actually functions in the same way that I functions, as in that when the loop is over, the I and the a kind of disappear and they're not nowhere to be seen. And this also works with if statements, for example. So we just said if true, so that means just that the if will execute, and we would say local a is a plus 1, and we just end this, and we just print it out. You'll see that this wouldn't change. But if I deleted the local one, what would end up happening that this a would be referenced to this one, which is global, but this one will be created new as a local variable. So hopefully this gives you a bit of insight what actually ends up happening with locality and globality of variables. So just to repeat, if you do send a function in a function, a variable, a new local variable is created with the same name if they happen to be the same, but it's not the same exact variable. But if you send an array in a function, that array ends up being the exact same array, which means if you change it in a function, it will also change outside of the function. So just one more thing I want to mention at the end, because this is kind of important, is that I mentioned writing functions like this, but what you can do is you can also store the functions in variables, and they work just the same. I mean, you would write them just the same as before. So let's just say that we have a function and we would give it a number, and we will just multiply the number by 2 for whatever reason. And now our function is actually stored in a variable called a. So that means that our function is not just a function, but it's also a variable. But we can use it as just as a function with the name a. So this is actually, at least when we use the function, it's exactly the same if we did something like this and we would return the multiplied value of this function. But the difference here is that we can actually use this a as a function to kind of use it as a variable. So that means that we can have a function which takes a parameter which is also a function. And that's a bit confusing, and there are no good examples for this, or maybe simple examples that I can explain, but I just want you to know that this does exist, and if you ever see this, this is maybe how you would approach it. And just maybe, you know, if you start experimenting, you know that you can do some pretty nifty things with this. But just at this time, you know, don't worry about it, because the functions already are a bit confusing, and the fact that you kind of have to know that functions are also variables, which are its own type, is just a bit too much, I think, for the time being. So for now, just remember that or functions can be stored as variables, and then you can use those variables as regular functions, and you can send them to functions as parameters, or just do anything you would do regularly with functions. So with that said, let's go to our actual example to just show you a bit more on how we can actually use functions in actual programs to kind of make certain things happen. Okay, so our first example wants us to create a few helper functions that do the following things. Prints out the array we put in as a parameter, returns the average value of an array as a number, returns the enemy which has the highest health or their index in an array, so which enemy by its index has the highest health in an array. It wants us to create a function which returns an array that indicates which enemies we can kill in one hit, and the last function which wants us to return an array of enemies which can kill us in n number of hits, and n is a number that we sent in as a parameter. So that means that we can put in 1, and that then we figure out which enemies can kill us in 1 hit or less, or we can put the number 5, which indicates which enemies can kill us in 5 hits or less. The 4 things that we have given to us as our base of code is the array enemy damage, which has values of 4, 7, 10, 15, and 2, and enemy HP, which has the values of 4, 6, 1, 10, and 2, and then we also have our own HP, which is 12, and our damage, which is 5. And you can read the arrays of enemy damage and enemy HP as the first pair is the damage of the first enemy and the HP of first enemy. So that means that our first enemy has 4 damage and 4 health, and our second enemy has 7 damage and 6 health, and our third enemy has 10 damage and 1 health, and so on. So I urge you to kind of create these functions for yourself if you can. Of course, there's always a solution at the end, but this is mostly just kind of trying to see if we can create the things we've already seen before and kind of put them into functions. And the great thing about it is when you create a function, you can use it in any program. You don't have to rewrite that code ever again. So they're very useful to kind of organize your code. So with that said, let's jump right into the solution. Okay, so our first example wants us to create a few functions. So you can consider this as more of multiple examples in one, but just because we have seen many of these things, I didn't want to split them up too much because I think it's important. The main plan for this example is to kind of rewrite the things we've already seen as functions that we can use maybe in some other programs later down the road. So our first function wants us to just print out an array. So it gets an array as a parameter, and then we print it out simply like we've seen before. The second one wants us to return the average value of an array. So it gets an array that's filled with a bunch of numbers. We calculate the average value of that array and we return it. The third one is we return the enemy which has the highest health. So we want to return the index of the enemy which has the highest health in an array. So in this case, for example, that would be index 4 or number 4 because our fourth enemy has the highest health in this array. The fourth one wants us to return an array that indicates which enemies we can kill in one hit. So our damage is 5, and we have enemies that have 4 HP, 6 HP, 1, 10, and 2 HP. So we could kill enemies 1, 3, and 5 in one hit, and what this function wants us to do is to return the numbers 1, 3, 5 in an array, because those are the enemies we can kill in one hit. And the last one is a very similar principle. We want to return an array of enemies which can kill us in n number of hits. So not one hit, but the n is sent in as a parameter. So that means that maybe we're looking for enemies which can kill us in at most 2 hits. So that means that if our HP is 12, the first enemy can't kill us in 2 hits or less because they only deal 8 damage to us in 2 hits. The second enemy deals 7 damage to us, so they can kill us in 2 hits. The third enemy deals 10 damage to us, so they can kill us in 2 hits. Of course, the fourth enemy can also kill us in 2 hits, so we would return that value as well. And of course, the last one, which does only 2 damage, won't be able to kill us in 2 hits. So we want to return an array with numbers 2, 3, and 4. So let's just look at the functions. So print array, what it does is loops through the array, and what it does, there's another check in there. So if we are at the end of the array, we don't want to output a comma, because what ends up happening is you would have numbers and then a comma at the end, and that's maybe not the most aesthetically pleasing, so I just put another check inside to see if we are at the end of the array, we want to output a comma, but if we're not, what we're going to output is the value and then a comma and then a space. So things look a bit neater, so they're outputted like this. So then the next function is we would calculate the average. So what we do is iterate through the array, we sum up all the numbers in that array, and at the end we divide it by the numbers of elements in the array. So if you don't know what an average is, maybe is you just add up all the numbers and then you divide it by how many elements you have. And as it stands out, the actual length of the array indicates how many numbers we are dealing with. So that is the second part of the equation, which then gives us the average back. So our third function finds the highest value in an array, and that is just something we already seen before a few times. It's also a function I wrote while the tutorials were going on, but just as a quick recap. So we check the array, we remember the first number and the index 1, and then we check if the second number is bigger than the current biggest number, which is the first number. And if it is, we remember the second number, and if it's not, we just remember the first number. And then we check the third number. Is third number bigger than our current biggest number? And if it is, we remember that number and the index of that number, and if it's not, we go to the next one. And you say, is this bigger than our current biggest number? And let's say it is, and then we remember that number and the index of that number, and when we go through the whole array, we're guaranteed to find the biggest number and the biggest index, and this function just returns the index of the highest value in an array. So this one is maybe a bit more complicated in the fact that this is something that we haven't done before, but we are looking at which enemies we can kill in one hit. So that means that we are able to deal more damage in one hit than they're able to withstand. So we create a new array with indices, and this is the array we're going to be returning at the end. It's going to have all the indices of enemies which we can heal in one hit. And we'll also create a new index of this array, which will increment every time we add a new enemy in our indices array. So what happens is we go through this for loop through the enemy HP, and we'll check if our damage is bigger or equal than our enemy HP. And if it is, it means that we can kill them in one hit, and we're gonna add this enemy to our array at the spot at the index of 1, because indices of index is 1, and then we're gonna increment it. And then maybe the second enemy in the enemy HP will not die in one hit, so we're not going to do anything, so this if won't be triggered. And let's say on the third enemy we'll be able to kill again in one shot. We'll add that enemy in our indices array on the next spot, because remember we incremented that before we added the next enemy, and we'll add the index of that enemy, so the third enemy. So our array would consist of 1 and 3 now, which means it has 2 spots, but it holds 2 values or 2 indices, which indicate that we can kill the enemy number 1 and the enemy number 3 in one hit. And then we would increase the index again. So if you just kind of simulate that on here, what ends up happening, so we have an indices array, which is at this point empty. So we would check, okay, so is our damage higher than the enemy HP, or the first enemy HP? It is. So what we do is we write that in. We would say index 1 is an enemy. I pressed F1 by accident. So index 1 is an enemy that we can kill in one hit. Okay, so is our second enemy, can we kill them in one hit? Well, we can't, because they have 6 HP and we are only able to deal 5 damage. Okay, but our third enemy, can we kill them in one hit? And we can, and we would put in our array an index of 3. And then we would check the fourth enemy, we can't kill them in one hit, and the fifth enemy we can kill, and we would also put that inside. So our array that we get returned at the end is 1, 3, 5, and those are the indices of enemies we can kill in one hit. And then the last function, which we kind of calculate by how many hits an enemy can deal to us before we die. So that means that the n is completely up to you, so it can be 1, which means we're checking how many enemies can one-shot us, or if the n is maybe 3, we're checking which enemies can kill us in 3 hits or less. So just like before, we create a new array called indices and a new indices index, which just kind of keeps track of how many indices already are in this array. And we go through the whole enemy damage array, which indicates how many damage enemies have. And then we calculate basically how many hits it would take for the enemy to hit us. And that is done just by dividing, or maybe you can multiply, or any way approach it. But the one I chose here is just division. So that means that if we have 12 HP and the enemy deals 4 damage to us, that means that they are killing us in 3 hits. And then we compare that to our n, which indicates how many times we want to know if that gets hit. And then the whole process from before is replaced. So if this is true, then we're going to add an indice of the enemy which can kill us in n hits or less into our new array indices, and we will increase the indices index by 1, and at the end we'll just return all the enemies which can kill us in n hits or less. And if you run this, you can see the first thing that gets printed out here is the average damage of enemies, and that's 7.6. And then what gets printed out is the average damage of NHP, and that's 4.6. Then is the highest value of enemy damage and enemy HP, so those are the indices of those enemies. So you can see that the enemy number 4 does have the highest health and also has the highest damage, or the other way around. Then we will print out which enemies we can one-shot, and that is 135, and that is exactly what we kind of saw before. So if you wanted, we can one-shot enemies 135 because those are the enemies that have 5 HP or less. And then we just print out 3 more numbers which are different depending on how many hits we take. So we're wondering which enemies can kill us in 1 hit, which enemies can kill us in 2 hits, and which enemies can kill us in 5 hits. And when you kind of generalize your functions in this way, they become much more useful, because this function is just which enemies can one-shot us, but this also works as a function to check which enemies can one-shot us, but it also works as a function that can check which enemies can 2 or 5 or maybe even 12 shot us for whatever reason. So we can check that the enemies that can one-shot us is only the 4th enemy. And that's exactly correct, because they're the only enemy which have more damage than we have health. And the enemies which can at least 2-shot us are enemies 2, 3, and 4, and that's exactly right, also because this deals 14 damage, 20 damage, and 30 damage, as opposed to our 12 HP. And then we check which enemies can 5-shot us, and those are enemies 1, 2, 3, and 4, and of course not the last one, because the last one only deals 10 damage to us in those 5 hits. With that said, that's it for this example. I hope that you learned something from it. It's maybe a bit more complex than usual, and I don't blame you maybe if you didn't figure some things out, especially these parts can be a bit confusing, but I urge you, of course, download the code, play with it, it's in the description like always, and hope and kind of see to figure out where things go from there. Okay guys, thank you for watching today. I hope you enjoyed it. It was quite a different episode maybe than most, just because we were focusing on functions so much. Maybe I skimmed over some things because I didn't want to complicate it too much, because I remember when I was teaching myself functions, they were very confusing for me at the start, but with time, you know, when you get some experience, I assure you that functions will become your best friend, because they are so very useful to us in just everyday coding. If you have any questions, because these topics are getting quite out of hand, please leave a question. I hope that these tutorials are kind of giving you help, or maybe some more insight into things that you haven't had so much insight before, and that I'm actually helping you learn. So of course, ask questions if you have any. And with that said, guys, I thank you for watching, and I hope to see you next time.